Hello everyone, I'm Davide Taibi and I'm going to present our work on the independence between architectural smells and code smells. The work has been published in the Journal of System and Software in 2019 together with my colleagues Francesca Arcelli Fontana, Valentino Lenarduzzi and Riccardo Roveda. So what are code smells and architectural smells? Code smells are something that smells bad in the code. In other words, there are structures that can cause negative effects. Different works from different authors demonstrate that code smells can decrease maintenance, can decrease analyzability, and the code understandability sometimes is also lower, and they recommend to refactor code smells. So whenever there is a code smell in the source code, it should be refactored. An example of code smells is spaghetti code. I guess everyone is aware about what is a spaghetti code. And an example of architectural smell might be a cyclic dependency. So dependency in between is class that depends on B, that depends on C, and again depends on A. There are several types of architectural smells and code smells. And in this work in particular, we want to understand if the presence of the architectural smells is independent from the presence of the code smell. The reason is that in case it is the presence of a code smell also imply the presence of architectural smell, then we would not need to calculate it. We don't need to use some special tools to extract this information about the architectural smells. And as some of you know, extracting architectural smell is something complex. It is something that requires special tools, and practitioners are not really aware, or they are not really using those tools for extracting architectural smells. That's why if we can really do it with only calculating code smells, then it would be really, really great. So the second is a bit more higher grain. So it's the presence of multiple architectural smell independent from the presence of specific code smells. And the last one is even higher grain. The presence of an architectural smell is independent from the presence of a category of code smells, so group of similar type of code smells. So for conducting these studies, we took the 111 projects, Java project from the Qualitas corpus. We calculated code smells using the PTDage plugin from SonarQube that we developed in the past, and then we extracted the code smells, the architectural code smell using Arcan. Results from SonarQube returned only 103 projects because the remaining projects were not analyzable. They were too big for our server. So in the end, we calculated the correlation between those two groups only on 103 projects. So what's the result? On one side, so for the first research question, when we analyze the presence of architectural smell versus the presence of code smells, here you can also see the list of code smells versus the architectural smells that we consider, is that unfortunately no dependencies between them were found. We did the analysis at the class level, and we did the analysis also at the package level. We did the analysis project by project. We did the analysis merging all the projects as in one single giant project. Results unfortunately do not change. Then we try to be a little bit higher grain to check if the presence of a multiple architectural smell was independent from the code smell, but the results, again, unfortunately, were not different. So we didn't find any dependency between multiple architectural smell and a code smell. And last round, so the presence of architectural smell is independent from a category of code smells. For the category, we use the categories proposed by Mika Mantula, and we compare those categories versus the architectural smells. As you might expect, results are still the same. No dependencies between them were found. So, in conclusion, we can say that architectural smells are something different from code smells. Therefore, you cannot derive architectural smell using code smells, but you need to use a special tool. You need to extract differently, you need to calculate differently. And we also believe that architectural smells deserve much more investigation, especially to understand when and how they are really harmful. For example, are architectural smells really increasing fault proneness, change proneness, decreasing readability? And maybe we need also to define some better tools, or we need to advertise a bit more the existing tools to the practitioners, especially because in case they are really or actually harmful, it would be important to consider them as part of the technical depth from the practitioner point of view. So the link to the published paper is just below. Thanks a lot for attending this presentation, and bye.